Hey guys, we're going to get started on lesson 3.2. So let me present my screen. All right. So to get started with some vocabulary, these are actually terms that we talked about in the last lesson. Alternate interior angles. You can see an example here, same side interior angles, which sometimes are also called consecutive interior angles. An example here, alternate exterior angles, same side exterior angles, and corresponding angles. Okay. In the last class, we were just identifying what kind of angles they were based on where they were located. But today we're going to learn that if the lines are parallel, okay, and they're cut by a transversal, alternate interior angles are equal, alternate exterior angles are equal, and consecutive angles are equal. Same side interior angles are supplementary, and same side exterior angles are supplementary. So just remember that same side, the ones that start with the letter S, they're supplementary. It's like a little hint for you, okay? Also, recognizing different angle pairs is going to be important because we're moving into proofs. So at this point, you should be familiar with adjacent angles. 1 and 2 are adjacent angles. They share a vertex and they share a side. Vertical angles, angle 1 and angle 2 in this diagram, opposite V's, they are vertical angles and they're congruent. Congruent angles are angles who have the same measure. Complementary angles, 2 angles that add up to 90. Complementary angles can be attached. They can be adjacent to one another, like in this diagram, but they don't have to be. They can be 2 separate angles that add up to 90 degrees. Supplementary angles, 2 angles that add up to 180. Again, you could have a pair that are attached, adjacent to each other that add up to 180, or 2 separate angles that add up to 180. When they are attached, this actually has another special name. We call it a linear pair. All right, a linear pair is 2 angles that are adjacent next to each other and add up to 180 degrees. They form a straight line. All right. So next, the theorems actually are pretty much what we just talked about up here, but we'll just read them in theorem form. All right, so the first says, if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So in the diagram, because I know that P is parallel to Q, that's given because of the arrows, that allows me to conclude that angles 2 and 6, those are congruent angles. All right, lines parallel implies corresponding angles congruent. Also 3 and 7 are congruent. We could also say 1 and 5 are congruent and 4 and 8 are congruent. All right, now as far as notation, what we're going to write as justifications for this theorem, we're going to say, where's my pen? Come on, pen. Oh, there it is. I'll erase that in a second. We're going to say parallel lines implies corresponding angles congruent. Okay, so when we move into the problems in just a moment, and definitely when we move into our proofs in a minute, that is the justification you would write if you were using this theorem. Okay, next, it says that if 2 parallel lines are cut by a transversal, then the pair of alternate interior angles are congruent. So the way we'd write that is parallel lines implies, you're saying, because I know the lines are parallel, then I know that alternate interior angles are congruent. So again, because these lines are parallel, I know that angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. Okay, because they are alternate interior angles. The next theorem, the alternate exterior angle theorem, says if 2 lines are parallel and they're cut by a transversal, then alternate exterior angles are congruent. So we're going to write parallel lines implies alternate exterior angles congruent. All right. And then the last one is a little bit different than the others. The last one says that if two parallel lines are cut by a transversal, then the pair of consecutive interior angles are supplementary. Remember, instead of consecutive interior, I call them, in some textbooks and worksheets, you'll see them interchange. I call them same side interior angles. I like the same side because then that reminds me that they are supplementary. So as a justification in a proof or in a problem, I'd say parallel lines implies same side interior angles sub. All right, we do a lot of abbreviating. Okay, so you kind of have to get used to the shorthand and know what everything stands for, but ask if you're confused. All right, so moving on, we're going to jump right into some problems. All right, so it says in exercises 1 through 4, find the measurement of angle 1 and the measurement of angle 2. Tell which theorem you use in each case. All right, so you're going to look and you're going to ask yourself, what do you know about angle 1 in relationship to the angle that's given? So you should be classifying them. Are they alternate interior, alternate exterior, same side interior, consecutive, alternate exterior, same side exterior, right? So because angle 1 and angle 2 are same side interior, I know they're congruent because the lines are parallel. So my justification for this problem would be parallel lines implies same, nope, not same side, sorry, alternate, there we go, interior angles congruent, alternate interior angles congruent. So angle 1 and this angle 110, they're alternate interior and they're congruent. So I can say the measurement of angle 1 equals 110 degrees, okay? Now, what's the relationship between angle 1 and angle 2? Classify them based on where they're located. They are corresponding angles. So you'd say parallel lines implies, you're saying, because I know the lines are parallel, that allows me to conclude that corresponding angles are congruent. So you can say the measurement of angle 2 is also equal to 110. Also, what's the relationship between angle 1 and angle 2? Opposite V's, vertical angles, right? Vertical angles are congruent. So they both should be 110, which we already said they were. All right, let's move on. Problem 2, what's the relationship between the 63-degree angle and angle 1? And then what's the relationship between the 60-degree angle and angle 2? Think about it. All right, because the lines are parallel, what do you know about angle 1 and the 63-degree angle? Parallel lines implies they're corresponding angles again. Corresponding angles congruent. So I know the measurement of angle 1 is equal to 63 degrees. All right, what's the relationship between angle 2 and the 63-degree angle? Look at where they're located. They're on the same side of the transversal and they're interior. So parallel lines implies same side interior angles remember they're supplementary, okay? So the measurement of angle 2 is going to equal 180 minus the 63, right? If they're supplementary, that means they add up to 180 degrees. So the measurement of angle 2 equals 117. All right. And then look at the relationship. What's the relationship between angle 2 and angle 1? They're a linear pair. They're adjacent and supplementary. So if angle 2 is 117 and angle 1 is 63, it makes sense because that adds up to 180. All right. Let's keep on moving along. Let's pull this down a little bit. Okay. So now what's the relationship between angle 1 and the 95-degree angle? And then what's the relationship between the 95-degree angle and angle 2? Well, hopefully we see that they are vertical angles, which has nothing to do with the parallel lines. So I'm just going to say vertical angles congruent. So because vertical angles are congruent, I know the measurement of angle 1 equals 95 degrees. Right? This is also a 95-degree angle. Now, what's the relationship between angle 2 and the given 95-degree angle? Or what about 1 and 2? You can use either relationship. 1 and 2 are alternate exterior angles. 95 and 2 are corresponding angles. Either way, we know the measurement of angle 2 is also 95. So I'm going to say parallel lines implies corresponding angles congruent. So the measurement of angle 2 equals 95 degrees. All right. Let me pull it down just a little bit more. Okay, so what's the relationship between angle 1 and the given, and then angle 2 and the given? Hopefully you can see it. Angle 1 and the given are vertical angles or opposite V's. So vertical angles congruent, that's what allows me to say the measurement of angle 1 equals 101 degrees. Right? This is 101 degrees. Now, what about angle 2 in the given, or angle 2 and angle 1? You could use either relationship. Angle 2 and angle 1 are alternate interior angles, which are congruent when the lines are parallel. Angle 2 and the given are what kind of angles? Corresponding angles, which are congruent when the lines are parallel. So parallel lines implies corresponding angles congruent. So I know the measurement of angle 2 is equal to 101. All right, let's keep on moving along. Okay. So it says in exercises 5 through 8, find the value of x, show your steps. You don't need to justify, okay, although justifying is always important. So maybe I'll justify the first few. All right. You're going to again see that we have parallel lines because of the arrow here and the arrow here. That's what indicates the lines are parallel. So as soon as I know the lines are parallel, I'm thinking about all those angle relationships. Alternate interior angles are congruent. Corresponding angles are congruent. Alternate exterior angles are congruent. Same side interior angles are supplementary. I know vertical angles are congruent. All that should be kind of floating around in your head. All right, so I know that I can set x plus 12 equal to 110. Now, if I was justifying why I know I can write that sentence, I could say parallel lines implies alternate exterior angles congruent. All right, from here, it's just an algebra problem. You're going to subtract 12 from both sides. And you're left with x is equal to 98. All right. The next problem. So what's the relationship between this angle here, 10x minus 55, and this angle down here? They are alternate interior angles, which are congruent. So you could say that 10x minus 55 is equal to 45. Again, if I was justifying in a proof, I'd say parallel lines implies alternate interior angles congruent. And then again, from there, it's just an algebra problem. I'm going to add 55 to both sides. So I'm left with 10x is equal to 100. And then divide both sides by 10. And you're left with x is equal to 10. All right. Let's go ahead and delete. Let me drag it down a little bit. Okay, the next problem. What's the, oh, my pen is starting to go crazy. What's the relationship between angle 6 and 52? And then 4x and 52, or angle 6 and 4x. So we have a few different things we can do here, okay? I know that the measurement of angle 6 is equal to 52 degrees, and the justification for that is parallel lines implies corresponding angles congruent. So I know that I can come over here and label this 52 degrees. Right? Now, what's the relationship between 6, or this 52-degree angle here, and 4x? They are a linear pair, right? They have to add up to 180 degrees. So I can say 4x plus 52, I'm talking about this degree right here, that angle degree, is equal to 180. And I know that because they're a linear pair. Oops, I was going to write pair instead of linear pair. That's the linear pair postulate. So after subtracting 52 from both sides, you have 4x is equal to 128. Divide both sides by 4, and x equals 32. Okay. All right, the next one. Look for the relationship between 153 and 2, and 153 and 2x minus 3, or 2 and 2x minus 3. We talk about that relationship as well. I'm going to actually start with angle 2 this time. The measurement of angle 2 equals 180 minus 153. Where did that come from? 153, not 152, sorry. 153. Where did that come from? It's because parallel lines implies same side interior angles sup. They're supplementary, right? Angle 2 and angle 153 are supplementary angles. So we're able to find that the measurement of angle 2 is equal to 27 degrees. Now, once I know that this is a 27-degree angle, what do I know about angle 2, the 27-degree angle, and 2x minus 3? Opposite v's, vertical angles. So I can say that 2x minus 3 is equal to 27. And I know that's true because vertical angles are congruent. And then from there it becomes an algebra problem. I'm going to add 3 to both sides. So 2x equals 30. Divide by 2x equals 15. Okay. All right, let me see. We are going to stop there for today, and we'll finish up this lesson tomorrow with looking at some proofs. Bye.